Hello. Today we're going to go over Algebra 2 concepts. It's from our book, section 8.3, and they are notes. Part 1, we're going to do this in 2 parts, and we are adding, subtracting rational expressions. So a lot of fraction work and some factoring. This definitely gets a little bit harder when we're going over concepts compared to when we're doing adding and subtracting. Alright, so we're going to start with a quick warm-up to remember our basic fraction rules because we're going to use those. And so again, you're always welcome to pause and try on your own, also welcome to move ahead. So the first thing I'm looking at, in order to add or subtract fractions, I have to have a common denominator. And as easy as these rules sometimes seem, especially since we're focusing on adding or subtracting, once everything gets mixed together, all 4 operations, sometimes we mix up our rules. So again, when I'm adding, subtracting, I have to build a common denominator. So I want to find the least common multiple. That way I'm doing less work. So least common multiple. So when I look at this and I have a base of 5 and another base over here of 15, I can take 5 times 3 and build that up. So I'm going to multiply the bottom by 3, and whatever I do to the bottom, I need to build to the top. I do have a lesson recording of a fraction review, which would be really great if you're uncomfortable with your fraction operations. So here we go. We have a numerator of 6, denominator of 15. And since this already had a denominator of 15, we didn't have to change anything. And when I add or subtract, I keep the common denominator. I have 6 parts out of 15, another 7. Think about having 2 pizza boxes. There were 15 cuts, there's 6 left. There were 15 cuts, there's 7 left. So we're going to take these 6 pieces and slide them over with that. So I have a total of 13 pieces left in one pizza box. That's what we're looking for. You may have improper fractions. They just always need to be reduced. All right, same idea over here. I need a common denominator, and I can't really take this 8 and multiply it by something nice to get 12. So this is where I'm going to change both of them. So I'm looking for the least common multiple, and so I'm going with 24. So I'm going to multiply the bottom by 2 and the top by 2. We need to balance that because 2 over 2 is 1, and so I'm really just multiplying by 1 in another form. So I have 22 over 24. Don't forget we're subtracting this time. And to get 8 to 24, I multiply it by 3, and I also multiply the top by 3. And that gives me 9 over 24. So again, I keep the common denominator of 24. I take 22 minus 9, I get 13. I want to double check if I can reduce that fraction, and that is in simplest form. So that is my answer. Okay, now, another quick review. This goes back to simplifying rational expressions. I have just a monomial divided by a monomial. So there's no addition or subtraction. I can just come in and reduce. 4 goes into 4 once. It goes into 12 3 times. So right now I have 1 over 3. The x's, the power subtract. So x to the 9th minus 3. Or we can cancel 3 of them and we're left with x to the 6. So you want a final answer of x to the 6 over 3. That's perfect. Since we're talking about this, we would also want to talk about a domain restriction. And the idea was that I had a denominator originally that had a variable in it. So I have a domain restriction that x cannot be 0. So domain restriction, again, it was in a prior lesson from section 8.2. Parts 1 and part 2. The denominator cannot equal 0, so we set the denominator not equal to 0 and we solve for it. So x cannot be 0 is part of our answer. All right, when I want to go do this, unlike this problem where I can just cancel out the x's, I cannot cancel or reduce these x's. I cannot cancel these 1's. What I have to do here is factor. You cannot cancel because I can't take an x out of all of them. Again, these are prior lessons, and so this is just a quick recap and review. So I'm going to factor this as a difference of squares, x plus 1, x minus 1. And then because they're like terms, I can cancel 1 top, 1 bottom. Be careful, this is left in the denominator, so it's 1 over x plus 1. And we want to talk about a domain restriction. What can't x equal? All right, well, looking at this, go back to your original denominator. Your original denominator can't equal 0. So x cannot be 1 or negative 1. So x cannot be a positive or negative 1. And again, that domain restriction is very important to your answers because it is going to affect later when you're solving these. All right, we have one more problem, and again, I cannot cancel or reduce anything. There are 6 pieces, and I can't take something out of all 6. So factoring is key here. So go ahead and factor that top. I have an x times x. I'm going to have a minus 8 and a plus 6. All right, down in the denominator, I'm going to have an x plus 6 and an x plus 4. It's very important that you double check your factorings. It's also important that you check, your numbers, that they do multiply to the right sign and add or subtract to the correct number with the right sign. At this point, I'm going to go ahead and cancel the x plus 6. Everything else that's left stays, so x minus 8 over x plus 4. And then I'm going to look for a domain restriction. So go back to your original denominator. It cannot equal 0. And so we're using zero product property. X cannot be negative 6 or negative 4. Negative 6 or negative 4. And that is our final answer with the domain restriction. Okay, so we're going to bring it back to something basic again. We're going to add or subtract rational expressions with similar or common denominators. So these are really easy. We just keep that common denominator. I don't have to do any extra work, and we add the numerators. And it doesn't reduce, so my answer is just 4/5. All right, this one, same deal. We have a common denominator. 6 minus 4 is 2. Double check to see if it reduces, and it does not. So we're going to start with common denominators just to get a sense of what we're doing. All right, now, what you want to notice in the directions is that we are to add or subtract. So don't confuse us with multiplying and dividing. And we want to identify any x values for which the expression is undefined, meaning we have a domain restriction. And again, you'll see me refer to the domain restriction as a DR. And the domain restriction comes from the fact that the denominator cannot equal 0. So again, prior knowledge, we're using it again. So when I look at this, the first thing I notice is my denominator is x plus 3 on both of these. So there's no factoring that I need to do. Nothing's canceling. I cannot cross cancel in addition and subtraction. Okay, I can only cross cancel in multiplication. Division, we multiply by the reciprocal, and then we can cross cancel. So we need a common denominator, no canceling here. So what I'm going to do is keep my common denominator of x plus 3, and what I'm really doing is adding like terms. So I would not take the time to write all this typically, but I want to show you that I'm really taking 3x minus 4 plus that 2x plus 5, just like we did with the numbers. We keep the common denominator, we add the top. So this ends up being 3x and 2x is 5x. The parentheses are only here to show the grouping. Okay, I'm not multiplying. And negative 4 and positive 5 is a positive 1, and it's all over x plus 3. Now, once I've combined terms and simplified it, what I want to do is double check, does anything factor and cancel? And in this case, it does not. So this is my final answer. And down here it says the expression is undefined at. All right, so really, what is our domain restriction? That's what this is asking for. And it's the idea that my denominator, before anything was canceled, cannot be 0. So it's defined, it's undefined at x equals negative 3. So the expression is undefined at x equals negative 3. But if I'm talking about the domain restriction, I would state x cannot be negative 3. So it's undefined when x is negative 3, meaning the restriction is the fact that we don't want x to be negative 3. That means it can go, x can be negative infinity up to, but not including negative 3, or greater than, but not including negative 3. All right, so I'll just put that in my box, and there we go. All right, so I have another problem here. And when you look at this, originally I thought, oh, maybe that denominator needed factored. I see the x squared, that there's no factors of 2 that add up to 0. So that's not going to factor. But here's where we need to be careful. That minus sign, that's going to get us time after time. So my suggestion, and this is years of doing this, is that you distribute that sign. Now, I already have a common denominator, so I don't want to change that. So what I'm going to do is I'm going to distribute this like I'm multiplying everything by -1. Anytime you're doing these, you're really treating these as if they're in parentheses. And so by me treating these like they're in parentheses, I'm really subtracting all of this. So I want to make this addition of the opposite and opposite. Most mistakes made, if people understand how to do these problems, are because of a sign change issue. So you want to distribute that. That's going to help you. And then I already have a common denominator, and that common denominator stays as x squared plus 2. And I'm going to add my numerators. Some of you might have looked at this and said, well, I could factor out a 4. Factoring out doesn't help me right now because I need to add my numerator. So I have a 2x and a -4x. And that gives me a -2x. And I have a -1 and a -4, which is -5. So once I put this together, I'm going to take a look at it and see if I can do any factoring and canceling, and I cannot. So for me, this answer is perfect. I would look for a domain restriction, and there are none. And the reason there's no domain restriction here is everything I square is going to be positive. And no matter what I square, it's positive. If I add 2 to it, it will never cancel out. So there is no domain restriction because my denominator will never cancel out to be 0. All right, one more thing I want to show you. This answer works for me, and I'm happy with that. But you might see another version of the answer, and it might have a negative sign out front like that. And so what I want you to understand is if I see a negative sign out front, it's almost like this one was out front. And I want to make that look like it's red there. And the idea is that would really distribute to everything in the numerator. So if I would have taken this -1 and said, okay, now it's 2x plus 5. This is equivalent also. What I did was I factored the -1 out, and then instead of having -1 times it, I just brought the -1 out front that would distribute to everything. So I just want to make sure that we're aware all of these answers are there. Where is it undefined at? It's defined for everything. So it is defined for all real numbers. Defined for all real numbers. All right, so there are a couple problems here for you to try and check it out. And again, you're going to want to add or subtract and then talk about any domain restrictions. So this is a good time to pause and give it a try. All right, so again, these are a little bit easier because we already have a common denominator. We're building up to that. So I'm going to keep my common denominator of x squared minus 3. And then I'm going to add, because I have a common denominator, I'm going to add like terms in the top. So this really becomes one big addition problem up there. So 6x and 3x is 9x. And then I have a 5 and a -1, which is a positive 4. Now, before I think I'm done, I would look to see if anything factors and anything cancels, and it does not. So this is my answer. Let's talk about a domain restriction. What can't x be? Well, these numbers aren't as pretty, but we're looking that our denominator, x squared minus 3, cannot equal 0. All right, so when I go to solve this, I add 3, so I do get x squared equals or does not equal a 3. So this is different than the one. This one up here had x squared plus 2, so I'll never get a negative out here. If we would have solved this, we would have gotten x squared equals -2, and that doesn't happen unless we have imaginary numbers. But for this one, I get x squared equals 3, or does not equal 3, and then to solve it, I would take the square root. And whenever you're solving a quadratic, you want to remember you get a positive or a negative option, because the square root of 3 squared is 3, and then negative square root of 3 squared is 3. So my domain restriction is actually a positive or negative square root of 3, or you could give the decimal value. I'm just keeping it exact there. All right, so we have this one. The first thing I want to look for is what operation am I doing, because it can get very confusing once they get all mixed together. I am subtracting, and so the key idea, I would honestly go through and change all the signs. These problems are fairly simple. I already have a common denominator of 3x minus 1, so there's not a lot going on. I'm not factoring, I'm not building. However, once these problems become more complex and there's more steps, it's very likely that you're going to miss this negative sign. And here's what happens. You see the 3x squared minus 2x squared, and you get x squared on top, and that's great. And then you see, okay, there's nothing here, so I'll write negative 3x. And you just missed it because it really should be minus a negative 3x. So that's why I suggest changing all of the signs. So multiply everything by -1, or addition of the opposite, and opposite. And that really does make a difference for you. So now I see that I have a positive 3x, and then I have a -5 and a positive 2, which is a -3. Now, next thing I would be doing is I would try to factor this. It does not factor. It doesn't cancel with anything. You cannot cancel pieces. You have to cancel factored pieces. So that is my answer. And let's talk about our domain restriction. What can't x equal? All right, so we would take our denominator, 3x minus 1, and set it so it does not equal 0. So a lot of us can do that in our head, and we've got the 1/3. But if you're unsure of that, just like solving them before, add 1 to both sides. You get 3x cannot equal 1, and then divide both sides by 3. And that's where I got that 1/3 from. Okay, so now we are going to start building our concept. So when we have a common denominator, we add up the numerators, keep the common denominator, check for reducing, get a domain restriction. Now we're going to back it up and start a little further back. So let's get our next part. And we have this idea that is we will need to add or subtract rational expressions with unlike denominators. We're going to have some work to do. So the first thing you're going to do is find the least common multiple, and then we are going to build them. So if you want some quick steps, these came from our textbook, to find the least common multiple of polynomials, you're going to factor each polynomial completely. Factor each polynomial completely. And then the second step that you're going to do is you're going to build each term to have the same factors. So build each term to have the same factors or the same pieces. All right, so we're going to start off without looking at rational expressions. We're just going to look at two pieces here. And so if I need to build this to have a least common multiple, that's what we're trying to do, is a least common multiple. When would I do this? If this was in the denominator, okay? If these were in the denominator, I need a least common multiple. So least common multiple between 2 and 3 is 6. And the least common multiple between x to the 3rd and x to the 5th is x to the 5th. So I always talk about the least common multiple being an oxymoron because we're using the term least, but everything is bigger. Because 2 and 3 multiples, if I count 2, 4, 6 multiples of 3, 3, 6, 9. So 6 is the first common multiple they have. If this has x to the 3rd, that already has x to the 5th, so I have to bring this up to speed. So even though it's a least common multiple, I am building it up. So if this has 5, I'm going to have to put some more pieces here. And I have y to the 4th and y to the 3rd, so this has 4, I'm going to have to put another piece here because I am building the multiples. And that would be my least common multiple. So I can do this because this is a product. Okay, these are all multiplication, so I can do that. If I try to build this up, a lot of people just want to put a 2 here. I can't just change one piece. So in order to build a common multiple when I have addition or subtraction, I need to have multiplication. So the first thing is to factor. Okay, that was that first step. Factor each polynomial completely. So pretend this is in the denominator. I'm going to factor this to be x plus 4, x minus 1. You really want to double check your factoring because you don't want to be off by a number or a sign. And then this one factors to be x minus 2 and x minus 1. And so those two negatives multiply to 2 and they add up to -3. So if you can take this and look at it, you can see that they both have the x minus 1. They both have that common piece. But this has an x plus 4, so this is going to need me to build an x plus 4 onto it. And this has an x minus 2, so it's going to need me to build the x minus 2. So what I'm doing is I'm building it by pieces. So my least common multiple is x minus 2 times x plus 4 times x minus 1. Now, I would leave this piece so I can see what I can do with it. All right, so here are some extra try it out for you. And you can see that I have just one term here and one term here. So common multiple in 4 and 3 is 12. Build up, if I have x to the 3rd, I have to build up, so x to the 5th. Y to the 7th, y to the 4th would be y to the 7th, because I am building up there. All right, so there is my LCM. Now, over here, I can't just build these. So I have to factor. You always have to be building with multiplication. And we're just building here to practice it. When we're doing it in a fraction, whatever I do to the bottom, I have to balance it on the top. If I had an equation, whatever I put on one side, I'd have to balance on the other. Again, we're just building right now for the sake of practicing. So this would factor to be x plus 2, x minus 2. Difference of squares. This would factor to be x plus 3, x plus 2. Be careful with this one. The 3 times 2 is 6, and they add up to 5. So if we look at this, we lucked out that they had at least one thing in common, but this one has an x minus 2, so I'd have to give that an x minus 2, and that has an x plus 3, so we'd have to give that the x plus 3. So you're always building to see what does one have that the other needs, and now they have 3 common pieces. So our least common multiple is x plus 3, x plus 2, and x minus 2. Now the order of your multiplication does not matter, so you might have it in a different order. Okay, so now we want to put this to work for us. Okay, so now we're really getting into this. We're going to add and subtract rational expressions with unlike denominators, and that means we have to rewrite them with the LCD first, and then we go back to adding. So this is going to start out easy, without big numbers, with a lot going on, but we are going to get into some more challenging problems, okay? But this should give you a good base to build on it. First thing I notice is I have a plus sign here. Second thing I notice is that I do not have a common denominator, and I want to remind you that even if this said x plus 1 up there, I could not cross cancel, because I can only cancel over multiplication. So the first thing I want to do is I want to factor this denominator. And I'm not a fan of rewriting a problem 1,000 times, so I'm just going to do this underneath here. So I have x plus 2, x plus 1. I'm going to double check it so I'm not basing it off of something that's wrong. So if you look, my denominator has an x plus 2, x plus 1. So this one's good. I don't need anything here. But this denominator only has an x plus 1. So I want to build that denominator. So what I'm going to do is I'm going to build this and put an x plus 2 on it. So going back to basics, what we started with at the very, very beginning, less abstract, when I did not have a common denominator, I built it by putting a piece to multiply the top and bottom because that's 1. And I didn't need to change this piece, I just had to change this one. So that's like what we're doing now. Now, there's times where I have to change both of them to build them both up. I change the bottom, I change the top. So a little bit more abstract, but the same base. If I put an x plus 2 down here, then I better put an x plus 2 up here. And I want you to notice that the idea that I have going on is that x plus 2 divided by itself is 1. So I am using my multiplicative identity. I'm multiplying by 1, it's just in a different form. All right, so here's where it gets a little messy. I have a common denominator, and my common denominator is x plus 2, x plus 1. Done. That's great. That's the easy part, okay? So I'm just going to let that ride. Now, as we work through this, you'll be able to do sort of less writing, but for right now, what I want to show you guys what I'm doing is I'm taking x minus 1 from over here, and I'm adding it to x times x plus 2. And so the reason I'm showing you this is because I can't add this when I have multiplication. So I'm taking this numerator plus this numerator. So what has to happen, because I built this up, is I actually have to distribute that. So I really have x minus 1 from the left plus x squared plus 2x. So here's what I have. Notice I'm still adding. I still keep my denominator factored. And so it takes some practice to wrap your head around that. Once I get my denominator factored, I'm going to keep it along for the ride. I'm not changing the denominator. This is my denominator and I'm keeping it until the end. But my numerator needs to be cleaned up. So in order to add these, I actually have to distribute this so then I can add like pieces, like terms. So now I have my x squared, that hangs out first. And then I have x and 2x, which is a positive 3x. And then I have my constant of -1. So that's my numerator. Now, before I think that I am done, I want to leave my denominator factored. Okay, and again, I'll start shortcutting this. And the reason I'm leaving my denominator factored is because I want to see if this factors. Are there factors of -1 that add up to 3? Okay, there's not. So I'm not saying that you can't solve this numerator for setting it equals 0, but it doesn't factor. And since it doesn't factor, it won't factor and cancel. So we are truly, once we get to this point and we add our numerator or subtract our numerator and we get our numerator over our denominator, we are actually right back to the warm-up problems we did. And so that's why we did this warm-up right here. Once I have this as a single fraction, we factor the top, we factor the bottom, and see what we can cancel. Okay? So that is why I left my denominator factored. It's almost like we pre-factored the denominator, and then up here I try to factor it. Now, some places you can leave the pieces. It depends on who is accepting your answers and if it's a textbook or what type of worksheet. But for my classes, once we get this top done and it doesn't factor and cancel, then we're going to FOIL everything out. So our final answer is x squared plus 3x minus 1. And then we need to take the time and FOIL out that denominator. And we get x squared. We get a 1x and a 2x, which is 3x. And then 2 times 1 is a positive 2. Okay, just like we've been talking about, we're going to talk about our domain restrictions. What can't x equal? The domain restrictions come from your denominators before you canceled anything out. So we had our denominator here, we built it up. This denominator cannot equal 0, meaning x cannot be -2 or -1. And that is the answer to our problem. So there are some steps to get involved in. So I'm going to remind you, the first thing we do is we factor each denominator and we build them up. Whatever I do to the denominator, I have to change the same to the numerator. Once I've done that, I actually need to multiply anything out so I can clean up the numerators and add like terms. But the denominator just comes along for the ride. It doesn't go away, it has to stay, but I keep it pre-factored. And once my numerator is cleaned up, I try to factor and cancel. If that doesn't happen, then I put everything back together, clean it up, find my domain restriction from the original denominator before anything canceled. All right, so let's look at another one here. This is x over x plus 3, and it says plus a -18. It could have said minus, so I would always watch that sign there. And the first thing I need to do is build it up. I can't just multiply by x and by a 3. I need to factor. So that's key. It's always factor. And that's the big ticket here. So this factors to x plus 3, x minus 3. The idea is if I can find the pieces, it's much easier to build. If you jump in and say, well, this has an x squared minus 9, I'm going to make this x squared minus 9, and this x plus 3, you end up getting higher powers and much messier things. So break it down and see that they both have the x plus 3 there. So they both have the x plus 3. This has an extra piece, so this needs that extra x minus 3. What I need you to see is that I didn't change this denominator, so I do not change that numerator. If this needed a piece, the numerator needed a piece. All right, so I have a common denominator, that's set. X minus 3, x plus 3. So that's the first thing I like to do. Just lay out my common denominator and I'm done. Now, for some of you, you'll just write this over top here, and you'll just say, okay, well, this is x squared minus 3x minus 18 and put it together. I'm still going to show this build. So this is the x squared minus 3x. So build that out. I'm going to put a big fat plus sign here and then a negative 18. So I'm making that plus sign to show you that this is the left side plus the right side. When I go to add like terms, there's really nothing to add. It's x squared minus 3x minus 18 all over x minus 3, x plus 3. Okay, so why did I leave this denominator factored? Because I'm going to try to factor this numerator. So the first thing you need to figure out, does it factor? And it does. We want to factor it correctly. So x minus 6, x plus 3. Double check yourself. And it's still over x minus 3, x plus 3. And so this addition and subtraction takes us right back to simplifying rational expressions like we did with one fraction or multiplication and division. And so you can see that the x plus 3's are going to cancel, and my final answer is x minus 6 over x minus 3. And again, we want those domain restrictions from the original denominator. So nothing ever canceled out. My denominator came down to this x minus 3, x plus 3, and so x cannot be 3 or negative 3. So you can see how much this is building. You really need to understand simplifying rational expressions because we've now built that. All right, so let's keep going here. We have a base, and at this point, we're now just doing a little more practice and paying attention to details. So you've got a good base for this lesson. So I have two problems for you to try. Again, this is a great place to pause the video and give them a try. Now, when I'm looking at this, the first thing I saw was building it up. Okay, I was like, okay, this needs a 3x minus 3, and that needs a 2x minus 2. But I need you to wait because you're making a mess. Did you go back to your basic rule of factoring? Okay, the basic rule of factoring is to take out the GCF. And if I take out the 2, I'm left with x minus 1. And if I take out the 3, I'm left with x minus 1. And oh my gosh, that just made it so much easier. So one of the things I always talk to my students about is looking ahead, and if you do a little bit of prep work, sometimes it makes the end game so much easier rather than just jumping in, okay? It's like actually reading the story and then answering the questions rather than trying to find the answers in the story. It will take you twice as long. So by taking a minute and seeing what can I do first, I now see that they both have an x minus 1. So really, I just need to build up my 2 and my 3. So if this has a 3, this needs a 3 because 6 would be my least common multiple. Now, what's confusing? There's a 3 there. That was there. I need to put my own 3 there. So don't forget about that. All right, now this has a 2, so this needs a 2 in the top and in the bottom. And I just wrote a 3 there. So again, whatever you do to the bottom, you do to the top. So that made it a lot easier. So right now, what is my common denominator? It is 6 and then x minus 1. There's my 6, there's my 6. They both have the x minus 1. Okay, on the left, I have a 9x. I'm going to put a big plus sign here. And on the right, I'm going to distribute that 2. That's why I use the parentheses. And I get 6x minus 4. Okay, before I'm done, I need to add like terms. So 9x and 6x. We end up with 15x minus 4. And in the bottom, I have this 6 times x minus 1. Now, some of you are going to look ahead and say, well, 15 and 4, they don't factor. So nothing's going to factor and cancel. So if I know it's not factoring, I might have skipped this step. Once I saw the 15x minus 4, I knew it didn't factor. I would go ahead and distribute this to be 6x minus 6. Again, you might see it in some places where they leave them unmultiplied out. They keep them factored. I will be multiplying them out. Let's talk about our domain restriction. Go back to your original denominator, or this denominator, before anything was canceled. It cannot equal 0. 6 will always be 6. It's a constant, but x cannot be 1. And there's our answer. Okay, Same idea. If I look at this and I say, okay, well, this has x squared plus 6x plus 9, and I try to multiply that over here, I'm setting myself up for failure. I now have powers of x to the third. I've got huge numbers. I don't want to do that. And then multiply this by x plus 3. Now I've got quadratics everywhere, cubics everywhere. What I want to do is I want to break it down. This is x plus 3 times x plus 3. Now, that's a perfect square. It's x plus 3 quantity squared, but I have two of them. So if you can see, I have one of them in common. And so this has an extra one, so I have to give this the extra one. And again, the parentheses are important because of the distribution that I have to do. So my common denominator is x plus 3, x plus 3. I'm going to show it both times, not quantity squared till later. And then at this point, some of you will just distribute this and add like terms. I'm going to continue to show that the left is x squared plus 3x. And so as you work at these, you can sort of do a little work off to the side. I'm showing it. And this stays as 2x plus 6. Okay, I've got to add like terms, so I've got x squared plus 5x plus 6. All right, I am leaving my denominator factored because I think that this factors and it maybe cancels. So I start looking at this and I realize, okay, my numerator is x plus 2, x plus 3. Okay, so that works. My denominator sticks as x plus 3 times x plus 3, and I see that they have a common factor. So I already had this prep, so this goes back to rationalizing or simplifying rational expressions, and since this is already pre-factored, I left it alone. That's why I leave the denominator set. It's one less thing to do, and now it cancels, and my final answer is x plus 2 over x plus 3. Domain restriction is that x cannot equal. Okay, so we're going to set this so it's not equal to 0. Well, x cannot be negative 3. So we get one idea for our domain restriction. Okay, there you go. So there are some basic addition ones that don't have common denominators. Key idea is to always look for something to factor. The smaller the pieces are, the better it is for you. All right, so really, I've already gone over this. Subtraction has all the same rules, but as soon as you see a subtraction sign, I think you should work to distribute it. Before you do anything else, distribute that first, okay? It's really going to help you later. Now, if I needed to manipulate my sign in the denominator, I might distribute that negative sign to the denominator. You either distribute to the top, everything, or to the bottom, not to both. So I'm always going to distribute to the top unless I have a reason to change my signs down here. Okay, first thing I want to do is look at this. Now, some of you want to factor this numerator, and you could, and that might help you sometimes. Sometimes you can factor and cancel before you even start. Again, not cross cancel, but just cancel. If I factor 2 out, I get x squared minus 8. Nothing's going to cancel there. But if I could, that might help knock something down. So there's times that you can reduce this and help yourself. So I'm going to leave that top, and I'm going to factor this to be x plus 2, x minus 2. All right, so that has the x plus 2. Then I need to build an extra piece of x minus 2 on it, and again, use parentheses to be proper and show that multiplication. All right, here we go. Common denominator, x plus 2, x minus 2. By distributing that negative sign first, I don't have to think about it. It's not something that I'm going to miss because I've already changed it. So now, instead of worrying about subtracting, I'm really just doing another addition problem. All right, so looking at this on the left side, I keep my 2x squared minus 16 since I didn't change anything. And on the right side, I'm going to put a big plus sign here. I do have some foiling to do. So I have a negative times a positive, so I get a negative x squared. I get a negative times a negative, so I get a positive 2x for my outer. My inside's a negative 4x, and my last is a positive 8. So I went ahead and foiled that. I showed the pieces. The next thing I'm going to do is I'm going to add like terms. So when I go to add like terms, I get 2x squared minus that. That negative sign really helps me by being distributed. So I get a positive x squared. I get 2x and negative 4x is negative 2x. And then my constants, negative 16 and 8 is a positive 8. Okay, now I am leaving my denominator pre-factored. I know that might be a hard thing to do because you think, okay, let's multiply everything out. So just to sort of repeat this because it seems like it's mixed up, the first thing I do is I look and break down my denominators. I'm focusing on getting a common denominator. That's my focus. And the numerator just comes along with it. Get a common denominator, build up the numerator. Maybe I have to build up both sides. Once I do that, I just keep my common denominator along for the ride. That way I don't have to focus on it. And then I clean up my left piece, my right piece, or any other numerators so I can add like terms. So I know it looks like it's pre-factored, but it's only a part of it. So I have to be able to put it together, and now I can factor the whole. And this does factor, all right? It factors to be an x minus 4 and an x plus 2. I just lied. They should not, yeah, x minus 4, x plus 2. Okay, I've got it. And this should have been a minus 8. That's what I'm missing. Sorry about that. I had a negative 16 and a positive 8. So if you caught that and you were telling me while you're talking to the screen, I just got it. So negative 16, 8, it wasn't factoring if it wasn't that way. So that's where I was stuck. Okay, and the bottom is x plus 2, x minus 2, and we can see that these cancel. And I am left with x minus 4 over x minus 2. And that domain restriction is the fact that x cannot be, let's go back to that denominator before we canceled, negative or positive 2. So that is the lesson. That's everything you need to know. And I have some extra problems for you to try. And I think it's really important for you to take a minute, pause this, and try it yourself. All right, the first thing I see that I am subtracting, I'm going to change that sign. Even though there's one number there, I'm likely to forget it. Very likely to forget it. Unfortunately, these denominators don't factor, so I'm going to have to give this one the whole thing, the 5x minus 2 and the 5x minus 2. All right, this needs the 2x plus 5 and the 2x plus 5. So this is one where I had to build both sides. So here's the easy part. Common denominator, 5x minus 2, 2x plus 5. That's the easy part. Now, I've got to build up my numerator so then I could actually put it together and see if it breaks down. So on the left, I have to FOIL. So it does take a little bit of time. These are definitely problems that you're committed to. So on the left, when I FOIL this, I better start over here. I get 15x squared. I get my outside and my inside to add up to a negative 16x and a plus 4. When I distribute on the left, that negative sign has to be distributed. That's why it's important to be there, because I might distribute a 2 and forget it. So it's really a negative 4x minus 10. So normally the big mistakes I see here are negative signs. All right, let's clean it up. I've got a 15x squared. Negative 16, negative 4 is a negative 20x, and a 4 and a negative 10 is negative 6. Now, before I take the time to do this, the first thing I would do is I would try to factor this, and that's going to take little effort, a little trial and error. Some of you might do something where you factor by grouping. I would have to try to factor this. I'm going to find out that this does not factor. So since it doesn't factor, it won't cancel. So I'm not going to rewrite this denominator. I'm going to go ahead and FOIL this denominator, and that ends up being a 10x squared. The outside and inside add up to 21x, and last is my 10. But again, I had to check to see if that factored. All right, let's talk about a domain restriction. What can't x equal? Go back to your denominator, and I have 5x minus 2. So some people might want to take this off to the side and say, okay, well, 5x minus 2 can't be 0. So I would add 2 and divide by 5, and I see that x cannot be 2/5. If you can do it in your head, this one you would subtract 5, divide by 2. It cannot be -5/2. Sometimes it's good to do it like this because you're less likely to mess up a sign or flip your fraction. So there is my final answer and my domain restriction. Okay, so looking at this next one, again, the minute I see subtraction, it's almost the same idea. When I have division, I stop and I multiply by the reciprocal. When I have subtraction, I stop and I distribute that sign. And now I don't have to think about it. My problem is much easier. First thing I want to do, does this factor? Okay, I know that the numerator factors, but it does not help me. Okay, I can take out a 2, but it doesn't help cancel anything. So I'm going to factor this as x minus 8, x plus 8. And so you can see that both problems have the x plus 8. So this one is the only side that needs a piece, which is x minus 8 and x minus 8. So again, here's the easy part. Common denominator, x minus 8, x plus 8. All right, where I have some work cut out for me, the left side of my numerator is 2x squared plus 64. If I had factored this out, I want to put it back together. And I have to FOIL this to clean it up. And so I'm going to get a negative x squared. I'm going to get a positive 12x. I get a positive 8 and a positive 4x. And then last would be a negative 32. Again, if you're getting something different, check your negative signs. Did you change it to a negative x and a positive 4? All right, now that I have my left side and my right side cleaned up, I'm going to add like terms. So I see that I have a positive 1x squared. I've got a positive 12x, and I've got 64 and negative 32, so I've got a positive 32. If you're not changing this sign here, you would have minus all of this and still have to consider changing the signs. All right, so in prior lessons when we added and subtracted polynomials, we practiced changing signs, and that's what should be helping you to see this. Before I FOIL this back out, I want to try to see if that factors. So I am taking a second to rewrite that denominator. Are there factors of 32 that add up to 12? Yeah, 8 and 4. So factor that, x plus 8, x plus 4. Double check because you don't want to have your factoring wrong. Keep my denominator, and we can see that those cancel, and my final answer is x plus 4 over x minus 8. And let's talk about that domain restriction. And that domain restriction comes from when I had my denominator not canceled, x cannot be positive or negative 8. All right, we have one more problem, and it looks a little different. But if you think about this, we're putting two ideas together, and we need to use our order of operations. So this is one of those things where I have to slow down. I really have a fraction divided by a fraction plus a fraction. When I go to add and subtract fractions, it has to be a fraction, so singular, not fractions. So I need a fraction plus a fraction. So I'm actually going to leave this x over x minus 3 alone. I'm going to focus on this first. I'm going to do my division first. And so I just mentioned this. We don't divide, we multiply by the reciprocal. So I'm really going to take this, and it's going to be 2x minus 6 over x squared minus 9 times the reciprocal, which is x plus 3 over 3x minus 9. Now, some of you would have factored that as you went, and I'm fine with that. So I would have been factoring, putting it down, factoring it, and flipping it. But I just want to show you where it came from. So again, I'm flipping here, and I'm changing that to multiplication. All right, that's what I did. This plus sign is staying here. I actually don't want to do this yet. So if I had to build a common denominator, and all I have is an x minus 3 here, I've got a lot of stuff going on. So I am still doing that first. So I'm going to factor this. 2x minus 3. Oh, that's awesome, because this factors to be x plus 3, x minus 3, times x plus 3, over, take out a 3, x minus 3. Oh, my problem just got a lot easier. I'm going to leave this over here, though. So I don't want to lose this piece. But I'm doing addition after I do multiplication. And since I have multiplication, I can cross cancel. So again, I cannot cross cancel unless I have multiplication. So you can see that the x minus 3 will cancel here, and it's a 1-to-1 ratio. So if I cancel these two, that one stays. If I cancel these two, I'd have an extra one here. The x plus 3 cancels there. And then the other thing I want to check for is I have a 2 here, and there's nothing out here that cancels with the 2. But if that was a 2 and that was a 6, then I could reduce it. All right, so on the left, I'm left with the 2 and a 3 and an x minus 3. And over here, I still have my x over x minus 3. So we took what seemed to be a really complex problem to add, and by taking the time and doing some prep work back here and factoring all the pieces and canceling out, just basically doing this problem. All we did was this problem. Once I do that and clean it up, now I have a pretty easy addition problem. They both have the x minus 3, and so this needs a 3 on the top and on the bottom. So what do I have? I have 2 plus 3x on the top, and on the bottom I have a 3 and an x minus 3. So I can look and see that this 2 plus 3x is not going to factor. So my final answer is going to be, maybe I'll write it over here, is going to be in standard form 3x plus 2 over 3x minus 9. And I know it's really tempting to get to the end and want to cancel these out because you're like, oh, how didn't I see that? You cannot cancel these unless you take something out of all of them. So that is my final answer. And I need to talk about a domain restriction one last time. And that domain restriction comes from several places. So I need you to come back to this idea that I'm dividing by this. I'm dividing by x plus 3, I'm dividing by x minus 3, but I'm also dividing by this 3x minus 9. So anything that follows a division symbol is a domain restriction. So I am taking my domain restrictions from here, so this cannot equal 0. This was the denominator down here. This was the piece from that numerator in the denominator, and then this piece here. So x cannot equal positive or negative 3. There's my negative, there's my positive, there's negative 3, and there's 3 again. So with all of that, I only had the domain restriction of x cannot be positive or negative 3. All right, well, I know this was a longer lesson because we did a little bit of extra practice at the end. I hope this helps you and you continue to practice. If some of this was hard for you, you might need to go back to prior lessons on fractions, on factoring, and on simplifying rational expressions. Thank you.